MP neuron to implement a Boolean function. A Boolean function takes 10 inputs. That is, McCall-Spit neuron implement the Boolean function. So the Boolean function represented in terms of zeros and ones only. That is, inputs are binary 0, 1, and output is also binary 0, 1. So Boolean function takes the 10 inputs. So Boolean input takes the 10 inputs. So that is 10 inputs. Number of inputs equal 10. That is from x1 to x10. That is x1 to x10, 10 inputs. And xi belongs to 0, 1. So given xi belongs to 0, 1, that is binary. That represents the Boolean inputs and produces an output, that is yi equals to, so that is output is also, so this is yi belongs to 0, 1. Assume that 0, 1 error metric is used. So remember 0, 1 error metric means it calculates the number of misclassifications. It finds the number of misclassifications means it classifies whether the class 0 or class 1 is used to count the number of errors so made by MP neuron. Find the number of, that is the number of means count. It represents the count of number of misclassifications by the MP neuron. Choose the correct statements about the MP neuron for the given configuration. They are asking correct statements only. They are asking first correct statement. So first option A, coming to option A, there exists at least one function. That is, at least means not less than, that is greater than or equal to one function. At least one function for which MP neuron cannot find a threshold such that it produces the 0 error. So when MP neuron it produces the 0 error, if it is correctly classifies the data points, given 10 data points, if it correctly classifies the 10 data points, that is class 1 or class 0 or positive class or negative class, it correctly classifies, that time only error equals to 0. Error is 0. There exists at least one function for which MP neuron cannot find means it does not find. That is, for example, XOR gate, it does not correctly classify the data points. So first option is correct. For this option, example is XOR gate. It cannot classify the XOR gate function. That is, it cannot classify the positive class and negative class data points. So error cannot produce 0. For this question, option A is correct because they are asking correct statements only. Okay, and manually find the threshold such that MP neuron produces 0 classification error for all possible functions. For all possible functions is not correct. So one can manually find the threshold. For XOR gate, we cannot find the threshold. For MP neuron produces 0 classification error. So error is not 0. 0 classification error for all possible functions. This option is not correct. Not correct. Next option C. So there exist at least 4 Boolean functions such that MP neuron can represent them with 0 classification error. Yes, it can correctly classify the AND gate. For example, AND function and OR function, AND function, OR function. There exist at least 4 Boolean functions such that MP neuron can represent them with 0 AND function, OR function, NOT function, and NAND, NOR, for example. So this option is also correct. It correctly classifies the AND gate, OR gate, NOT gate, and so many gates with classification error is 0. And next option is MP neuron must have at least one inhibitory input. Must have compulsory at least one inhibitory input to implement all the possible Boolean functions. It is also not correct. One inhibitory input, we cannot implement the XOR gate. We cannot implement. It's not possible. It's not possible to implement the XOR gate if we use inhibitory inputs also. How the inhibitory inputs means, inhibitory inputs acts as, if we give the input, for example, so MP neuron represent like this. Y is the output. It belongs to 0, 1. ఇది F function, G, F and G are functions. G given 10 inputs, x1 to x10, 10 inputs, that is xi belongs to 0, 1. The inputs are also Boolean function. So y equals to output equal to classified as 1 when the threshold function sigma I equals to 1 to n xi and 0 xi greater than or equal to theta. Theta is called the threshold. Theta is called the threshold function, and 0 for sigma I equals to 1 to n xi, that is less than theta. Xi is all the inputs sum is greater than theta threshold, less than theta if the output is 0. Inhibitory inputs are represented with inhibitory. For example, if we represent like this, this is the inhibitory input. If inhibitory input, for example, x3 is the